Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to introduce endogeneity. First, we're going to start with a general problem and its intuition. When x is not independent of the error. So far, we've covered several problems with OLS. So we've covered omitted variable bias, multicollinearity, heteroscedasticity. We step back and look at a more general issue that unifies several actually of them. And that is, what if our regressor is correlated with the error term? The key assumption in here that we're always doing in OLS is that the covariance between your x and your u is basically zero. So the regressor must be uncorrelated with the error term. This means x contains no hidden information about the u. Now, this is assumption 2 from earlier videos that we have seen, so or assumption 4, the zero conditional mean. Endogeneity is exactly what happens when this assumption fails. Everything we built on top of it, unbiasedness, consistency, will also break down. So what is endogeneity? Well, endogeneity means that now this covariance between x and u is actually not zero. X is correlated with the error term. Something in the error term, something we haven't measured, is also related to X. The word endogenous, by the way, by itself comes from generated within. Okay. So X is not truly independent of the process generating Y. It's somehow tangled up with things that we can't see. So why is this a problem? If X and U are correlated, it means that OLS picks up not just the effect of X on Y, but also the effect of whatever is hiding in that error term, which means that we're going to have biased estimates, which means on average what we're estimating is wrong, and mostly inconsistent estimates. So it doesn't get better if you add more data. And this is also a key difference from heteroscedasticity, because in heteroscedasticity, we had that the estimates were still unbiased and more data didn't make things worse. However, with endogeneity, coefficients are inconsistent and even infinite data is going to give you the wrong answer. When you look into this, some of you might think of omitted variable bias and actually ask, well, why is this different actually from the omitted variable bias that we have seen so far? The thing is, omitted variable bias is just a special case of endogeneity. Okay. The reason why is omitted variable z goes into the error term and z is correlated with x, then we'll have the covariance of x and u different from 0. Now, that's also endogeneity. So everything actually that we learned about omitted variable bias was really, in essence, about endogeneity, but we were just looking at one very specific source of endogeneity. That's why sometimes you'll have your lecture or maybe reading some of the books, omitted variable bias being called endogeneity. Keep in mind, it's just a very specific case of endogeneity where we know exactly where the source is coming from. And the main there are also other main sources of endogeneity apart from omitted variable bias. So omitted variable bias would be one of these special cases where, as we said, a missing variable affects both X and Y. The other form of endogeneity will be reverse causality. Okay, which means Y also causes X, not just the other way around. And another one is also measurement error. So X is measured with noise, creating correlation with the error term. So each source in here has a different story, but the consequence is the same. So the covariance of X and U no longer zero, which means that the OLS breaks down. We'll dedicate a video to each of these sources. Keep in mind, today is just the big picture for this video. Endogeneity means X is contaminated, which means it carries information that belongs in the error term. So if you think back to the regression anatomy, we had the Frisch-Louvel theorem that showed us that the beta hat is identified from the variation in X that is independent of everything else. Now, if that independent variation does not exist, because X apparently is tangled up with U, then we can't cleanly identify the beta. So this is, in a sense, also the deepest way to understand endogeneity, and that's why it's so interconnected with all of these other concepts that we have seen so far. And ultimately, it doesn't just bias the estimate, it literally undermines the identification of the effect entirely. Okay, so it undermines identification. Okay, the classic example, for instance, we've been using education and income quite a lot in the previous videos. Does education increase income? And the answer would be probably, but keep in mind, ability affects income directly. Ability also leads to more education, and ability is in the error term, we can't measure it. So education is endogenous, and the OLS estimate picks up both the education effect and the ability effect. So this is OVB. We've seen it through the actual videos of omitted variable bias, but at the same time, this is seen through the endogeneity lens. So we have the same problem, but now the framework is just a little bit broader. What we have to keep in mind is endogeneity is one of the central challenges of causal inference in economics. The main reason for that is because you literally cannot interpret any of the betas as the effects of X on Y, and at most you can say X and Y are associated, which is obviously a lot weaker and often not really what we want to know through a regression. The solution to endogeneity problems is instrumental variables. It's designed specifically to recover a causal effect when X is endogenous. So overall, endogeneity occurs when a regressor is correlated with the error term, making OLS estimates biased and inconsistent and preventing causal interpretation. In the next video, we'll focus on the instrumental variable, so stay tuned and I'll see you then.